My name is Igor. I work as senior software engineer for Cloud Composer, which is a managed Apache Airflow offering in GCP. Just so I have a better grasp of the audience, please raise a hand if you know what AAP stands for. Okay, some know, some don't. So AAP stands for Airflow Improvement Proposal, which is the way how Airflow as a community evolves the product. If you want to have something that doesn't fit into a single pull request, it's probably a good idea to have an AAP, so there can be a discussion and eventual consensus on whether or not to implement this feature in Airflow in the next versions. So today we'll be talking about some AAP 85, which we started working on like a year ago. And since then, there were a lot of things, the biggest one being the formal release of Airflow 3. So I want to talk a little bit and familiarize you with what we are proposing. Airflow 3 brought a lot of innovations in Airflow, but we believe there are still some improvements and some room for even more innovations around the DAG processing. Personally, my favorite feature in Airflow 3 are bundles, which were covered by AAP 66, implemented by Jet, who had the full talk dedicated for that yesterday. The main problems that it solves successfully is the ability to have a consistency of the version within a DAG run. It also gives you quite nice flexibility when it comes to the customization of when you want to fetch a new version of the code, and it effectively makes the versioned storages of your source code a first-party citizen inside of the Airflow. And it fits very nicely within the existing Airflow paradigm of eventual consistency on the side of the DAG processor, where you just drop the file, and depending on your configuration, eventually it will get updated, and you'll be able to run your recent changes. However, from our experience, this is not always ideal situations. In some cases, the users don't write exactly the perfect code, which means that the additional DAG parsing all the time, in addition to the fact that being additional CPU resources allocated for that, can result in the degraded DAG availability due to transient errors in the dependency. If some other AAPs will go through, like AAP 92, which introduces a stronger isolation similar to the one offered by Airflow 3 task SDKs to the DAG processing, it will have even more hops. So the higher availability, to have the same amount of availability, you will need to do additional work on the side of the DAG processor. It also complicates the continuous deployment quite a bit. It reduces a lot of complexity because since what you can do there is update the version, let's say if you use Git bundle for that, you still need to do a bunch of continuous checks to wait before it gets picked up for every single DAG out there. And only then you will get information about whether or not the error, there was some error, and you actually need to roll back the full thing back. In addition to that, it's pretty hard to do things like canarying, to updating only the subset to make sure that the new changes, which might include, for example, a library, which affects most of your DAGs, doesn't break everything. And of course, it's 2025, and we have a new kid on the block, with the AI agent being more and more part of everyday operation for the data engineers and developers alike. And AI agents really benefit from having a reliable and a fast way to evaluate the DAG that they have you to offer. Right now, you can, of course, work around these limitations. You can run continuous checks, but this means that either in the side of the MCP server, you will need to implement non-trivial logic of verifying that, yes, the DAG indeed got picked up by the DAG processor and got updated and parsed successfully without import errors, or you can just delegate it to the AI, but then you will burn quite some amount of tokens on those unnecessary checks. And even then, when it finally submits, it might not be available aware of the actual environment where it will execute the DAG, and the parsing can fail at this stage, for example, because the variable was defined on the dev environment by AI itself, but was not deployed to staging and prod. And of course, as a DAG author myself, this is my favorite thing to see. So what you can do if you were to have a strong consistency option to operate with DAG processor. Let me start with a short demo where we implemented a simple DAG processor server that implements two endpoints, which are also available in the simple MCP server. One called parse bundle, which does a read-only parsing of the DAG and returns the structure of the DAG or import errors, but doesn't actually upload it to the Airflow. And then the explicit action to upload it. So let's offer some DAG. Here, I will ask it to check what's the current weather and dump it into the GCS bucket that I created. And I will give it some instruction on how frequently to run it and ask it to verify, fix any errors that it will might introduce on itself. And finally, I'll ask it to upload it. I am using Gemini Code Assist with an agent which is currently in preview, but of course this would work with any coding agent of your choice. So here it produced some DAG. It's not exactly the highest quality. It squashed everything into a single thing, but it's good enough for a starting point. It also had some issues at first with parsing a bundle by providing an invalid path, but it was able to correct itself before I even had any time to intervene. So it successfully created a DAG. I can unpause it to check if it works. And sure enough, yes, I do have my JSON with weather. And of course, you can continue iterating on that. We can ask it to refactor the DAG and separate it into separate tasks. Let's see if it will be able to succeed on that. Yeah, it first reads the file. Since I already, yes, and here is the draft. And since it already allowed it to use the parse tool without my approval, because I know that it won't break the environment that I have running locally, it does that before it prompts me to confirm to upload the DAG. However, the code, you can still do some improvements. In particular, we can make use of the Google Cloud operator directly rather than implementing it in Python to make use of some of the features that we have, like better data lineage if you have it done with the operator. And sure enough, it refactored to the code as asked. And uploaded the DAG. Now, in this case, we were very lucky that the AI didn't make any real errors. In the reality, it will, of course, will always be the case. So, and I can always fall back for the number one source of bugs in my code, which is me. So what I did for next is I introduced some of the bugs in my the code that it produced and asked it to continue helping me write this DAG. So this time I will ask it to also check that the bucket indeed exists before it proceeds and create it if it's missing. And we'll see if it will be able to fix the error that I've introduced there. Okay, what it did is that it just creates a separate method that does the check without modification of anything else. Let's see if it will stumble on the parse error. It asks me for the name of the bundle that I use, because this is a new chat that I started with it, so it doesn't have the context. We allow it to use the parsing, and it immediately figures out that something is wrong. And yeah, sure enough, instead of source and destination, it's SRC and DST. So it was able to fix it, and now I can upload, and I know that it will parse successfully. Yeah, so how do we propose it to have it working? What we propose is to have an alternative mode of operation for the DAG processor, which will operate as a separate API, which will provide you explicit controls of when and how things are parsed. So you can have integrations with the event-based things like PubSub if you want to, or you can use it in your CI to significantly simplify the process of you deploying things. And of course, the AI agent can benefit it as well, because what you can do is you can configure it to run in the read-only mode, where it will draft the DAG in the dedicated workspace draft bundle, where it will not be allowed to upload it at all, and where you can configure it to only access the connections that are safe and to not accidentally drop your databases in production. This very much relies on another AAP that is still in flight, while AAP 72 is fully implemented in Airflow 3. AAP 92 is currently in draft, and what it proposes is to have a similar isolation to the task SDK, but for the DAG processing. And of course, once your agent verified that what it produced seems to be about right, the continuous delivery pipeline can process the submitted change and safely actuate it by first selecting a subset of the DAGs from the bundle to parse, only parse those, and once it sees that, okay, it's been 30 minutes and nothing crashing so far, it will proceed and update the whole bundle, otherwise it will roll back automatically. And with the new iterative DAG processor, we believe that those continuous delivery logic will be far easier to implement. This will require some extensions on the backend side of Airflow beyond the DAG processor API itself. In particular, for the DAG model, we need to introduce a concept of an optional default bundle version, which means that if you had a version bundle, like the Git one, you could pin the DAG model to always use this particular version until the interactive processor explicitly updates it. Okay, this is effectively the first part of this AAP, but there is also a second one. Another thing that we observe regularly with the users when it comes to DAG processing is how the DAGs are populated. Python is an extremely powerful tool, but sometimes the most powerful tool is not necessarily the right for the job. Very frequently, people want to opt in for some more simple configurations, which are either based on static ways to define pipelines, perhaps with some visual editors on top of it, or they want to run some other open source project like dbt core and bring the power of Airflow orchestration to that. So what we propose is the introduction of a new concept called DAG importer, which will have a one-to-one mapping with the bundle, and which will take care of how you construct a DAG out of the contents of the bundle. The way how it will work is that it will take care of providing the information about what paths are there available that are supposed to be file paths of DAGs inside the bundle. And then it will import those by returning you the Python runtime object, no matter what is the actual source code that you used there, because depending on how you configure it. It will require some modifications in the DAG processor. For example, one thing is that the things like listening the parse and fetching the metadata will be required to run in a separate process, because it will you might want to use task SDK there. And with listening paths, you will be able to use it, for example, to use the same abstraction of connection to connect some external source for the bundle. As the interface, we see it's something like this. You will have the most important method of importing the path, which will import you all the DAGs that are located into the subpath. And the second part is a different metadata about the bundle that the importer should be able to return. It includes the path themselves as well as some metadata, so the optimizations that we have right now around the only reparsing at a certain frequency, only if the DAG path is changed, won't be thrown away and would have to be re-implemented. To be clear, we propose the following split of responsibility between the processor, bundle, and importer. The processor is supposed to be still very much opinionated, and it is responsible for what DAGs are ingested and when those are ingested into the Airflow metadata database. And it's also the only component that is supposed to access it, preferably through the AAP 92 rather than directly. For the DAG bundle, it manages the source storage, and it also takes care of the version control return the information about like what are the adoption, the version that is available, as well as preserving this information in history, so it can be checked out if we request that actually we need an older version. While the DAG importer will also be configurable as a provider, just like DAG bundles are, and they are responsible for how you construct the DAG from whatever you have inside the bundle and what DAG paths exist there. So let me show a quick demo that I have. In this demo, what we did is that we took a visual editor of BigQuery pipelines, which is a very simple pipeline tool aimed for data analysts to run pipelines in BigQuery. And what we did is that we configured a custom DAG importer that directly imports those and syncs them into the Airflow without creating any intermediate artifacts by talking to the API directly. So as you can see, what I do here is I'm creating another action, put it in the graph at the end after all the actions are run. And after I save, magically, if I navigate to Airflow, to this DAG, ask it to reparse it, press F5 a couple of times, and I can see the task here ready to go and ready to make use of the power of Airflow, all of that without creating any additional Python files in the process. So while working on this, what we discovered is that we have the following compatibility between bundles and importers that would actually make sense. There are file system bundles, things like local file system, S3, GCS, Git. Those work nicely with the file importers, which focuses just on importing the particular format. For example, of course, you have Python, which is how Airflow is operating right now. You can have some other flavors of Python, like a Python notebook, or you can have some static configurations, like the one that we demoed for BigQuery Python YAML format. On the other hand, if you want to give to completely isolate the storage and abstract away from files, you can use a synthetic bundle, which will just provide a virtual path and pass the version to the importer, effectively shifting most of the logic there. And in this case, you can operate with external importers, like the one that was demoed, where you don't create any file artifacts locally. To clarify this point, this is how it was implemented in the demo. There is this synthetic file system bundle, which just provide a virtual path to use, and the importer configured on it. And the importer itself lists the paths by dispatching requests to the API to see what pipelines there are. And then it runs a sequence of requests to fetch the compiled pipeline and then translate it into the Airflow for the supported operators. While for version, the same can be implemented as a file system one, where you can use something like a Git bundle, and then you will do the compilation locally, and the list path will be just an OCA and a list directory for a certain configuration. So all of that is currently in the draft stage. So the most important request that I have is to please provide feedback if this is something that you want to see in Airflow, especially provide feedback if you don't want to see it in Airflow. That's an equally valuable feedback for us. You can find me in Airflow Slack, and you can also comment directly on Wiki or join the dev list thread, which is available on the tiny URL AP85 dev thread. So thank you very much.